Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSwitch Solutions. Get support and professional services directly from the creators of the FreeSwitch open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSwitch advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-CLUE.
And welcome to ClueCon Weekly. Today is the 26th of September, 2018. And this week we're going to have Ms. Carol Davids from Illinois Institute of Technology joining us. For you guys that don't know who Carol is, she is the director of the Real-Time Communications Lab there at IIT. And she's got a lot of experience, everything from Bell operators to even the IETF and some of the other standards boards. So we're going to be talking about communications and what they're working on there at the university and some other cool stuff today. So you guys stand by for that. First, let's go over to Miss Abby. I hear she's got a bunch of stuff for us today. How are you doing, Abby?
I'm doing great, thank you. Hi, everybody, and thank you for joining us today on ClueCon Weekly. If you have any questions during this call, please comment them in the YouTube, HipChat, or IRC channels, and we will do our best to answer them live during this call. And if you're watching us on YouTube right now, please make sure to give us a share and follow us on Facebook and Twitter and Instagram and LinkedIn to stay up to date with all of the FreeSwitch team. Now is the perfect time to follow us because a lot of exciting things are starting to happen. For example, FreeSwitch is going on the go. You can catch the FreeSwitch team at AstraCon in just 2 weeks at booth 101. You can see Evan McGee speaking at AstraCon at 10 a.m. on Tuesday and Thursday, and Anthony Minasali speak at 11:15 on that Wednesday. And you will definitely want to come find us during those evening parties because we are bringing a lot of fun stuff with us, including our exclusive SignalWire Cards Against Technology game. Ooh. So we are really excited about seeing everybody at these conferences, so make sure to stop by and see us. Other breaking news. Today is a day that will go down in ClueCon Weekly history because today is our very first blog spot segment. So every week for a while now, we've been posting a blog on our FreeSwitch website that discusses the different context of technology. And every week on ClueCon Weekly, we're going to start touching on some of these ideas. So 2019 is a little bit closer than you might think. So today we are going to be talking about 5 of the biggest tech buzzwords that we've seen in 2018. So tech buzzword number 1, artificial intelligence. Everyone's heard of AI. It's been in the spotlight for a while now. And while true AI revolves around machine learning, many marketing campaigns have taken this term and run with it as a way to make their products sound more impressive. For some reason, artificial intelligence just sounds way cooler than voice-activated personal assistant. Yeah. Buzzword number 2, XR. So virtual reality definitely is not a new concept. In fact, it's a little bit older than you might think, but the technology is definitely starting to become more popular as price points become more accessible. We currently have 3 different types of alternate reality. We have augmented reality, like Snapchat or Pokemon Go, where the animations are interacting with our real-world surroundings. We have virtual reality, which takes place in 100% computer-generated surroundings, and mixed reality, or hybrid reality, which is a mix of both. So they created XR, which is a brand new buzzword that's emerging as the king of the acronyms. It's used as an umbrella term for all computer-generated reality, old and new. Tech buzzword number 3, blockchain. Oh, blockchain. So over the last year, Google searches for blockchain have increased by 250%, despite the fact that the technology was invented back in 2008 as a public transaction ledger for Bitcoin. So since its invention, blockchain technology is working its way into many other applications, including voting systems and banks, as well as into our hearts. Aww. Simply put, very simply put, blockchain is a growing list of records or blocks linked using cryptography, and the cherry on top is that all of the transactions are publicly published and verified. Tech buzzword number 4, 5G. A clever marketing ploy or the next best thing since 4G. This buzzword is cheating a little bit because mobile phones equipped with 5G aren't going to be available until 2019. However, 5G is slowly being launched in the US throughout this year. Internet providers are promising us more bandwidth and less latency, which would make cell phone-based XR much better, faster, and downloading movies would be faster as well. So while 5G currently is predicted to be modestly higher than 4G, we cannot be sure how much faster until more substantial field testing is done. And finally, tech buzzword number 5, microservices. Microservice architecture is a trend used when developing software systems. Its focuses on building many single function modules rather than one single monolithic application. So the idea is that certain applications are easier to test and maintain when they are built in smaller pieces that can work together. And while microservice architecture isn't perfect for all applications, this tactic can make building a project much faster, much more resilient, and much more easily scaled. And while this isn't exactly a new concept, hello, service-oriented architecture. The term microservices is definitely gaining a lot of traction in the public eye. So that's it for our tech buzzwords today. Make sure to visit our Free Switch blog every Thursday and check in on every Wednesday for more updates on what's happening in the technology world. Thank you all for listening. Make sure to comment and share. Back to you, Ken.
All right. Thank you very much, Abby. So, hey, guys, we're going to jump over and get Mr. Michael Malvarudis in here. And I think he's got Mr. Jarris with him this week for Community Corner. Mike, how are you guys doing?
Good.
Great.
So, Mike, we have a question for you from the Free Switch users mailing list. And that question is from Raven Bat. And he asks, hello, I am using FreeSwitch 1.6.20. It's a fresh install with using the vanilla configuration. I want to renegotiate the codec when the call is answered, and I am using UUID Media Renegotiate API. Here's the scenario. User A calls user B, and both users negotiate the G722 codec. When I use the API to renegotiate the codec to G729 for the A leg, it's working fine. But when using the same API with the B leg, it's using G722. So, Mike, what's going on here?
It's a very good question. The first thing I would do is recommend, if you're doing new installs in particular, to not use old EUL versions. We have 181 released, and 182 we're actually in process of pushing to repos as we speak, as we're recording live ClueCon Weekly right now. So 182 will hit the repos today. So first and foremost, we fix hundreds and hundreds of bugs with every release. It was about 140 or 50 in 181. It's about 75 in 182, and it was about 300 or 400 with 180. Please be using the most recent versions out there before you try to do things. The upgrade path from 1.6 to 1.8 is not painful. It should be as transparent as a 1.620 to 1.621 kind of upgrade. please be using the latest FreeSwitch. That being said, I suspect that fixes the problem, but it doesn't really address why you have to do what you're doing in the first place. So FreeSwitch has a number of features for codec negotiation, and there's a great page on Confluence called Codec Negotiation, I believe, that talks about all of these options, but there's two main ones that I'll talk about here. I did read further in this thread, and basically he's trying to avoid transcoding between endpoints that speak 722 and 729. So the best ways to do that is to let the endpoints negotiate with each other and tell them which codecs they support. If you know that there will always be some matching codecs between them, there's three settings that come into play. First one being late negotiation. There's a couple ways to set late negotiation. You can read up on it. Late negotiation basically doesn't have FreeSwitch decide on the codecs until it exchanges codecs with the other side. That lets us send all the codecs through to the B leg and let the B leg pick the codec. Almost definitely you want to be doing that in this case. The second setting you want to be looking at is inherit codec. Inherit codec takes the codec that's picked on the B leg and tells the A leg to use that codec. And the third setting that may come into play here is disable transcoding, which does what it sounds like. It will fail the call if it has to transcode. You may or may not want that in this case. So in any call scenario where you're making an inbound call, taking an inbound call and sending it out to an outbound call, you can use these parameters to negotiate the codec across the path as opposed to trying to renegotiate it afterwards. And this allows you to avoid all of these issues of trying to renegotiate afterwards. I'm pretty sure that's the best path for you. Even in cases...
What about using stuff like, changing how the codec strings or the variables associated with how the strings are negotiated, and then also just changing the strings?
There's a couple ways. There's a parameter, I'm not going to remember off the top of my head. It's something like media mix codecs or something like that, that tells whether to add in additional codecs to the A leg, the additional codecs FreeSwitch supports. So in places where you may need transcoding, you have an option to either add the codecs we support or not add the codecs we support. And the other parameters involved.
That one came in on 1.6, right? That was new to 1.6?
1.6, 14, 15, 16, somewhere in there. There's a great email from Brian. That was a breaking behavior change. We hit an issue with WebRTC where the STPs were getting so large we were starting to routinely break MTU with all these new codecs. So we changed the default behavior on that to make our STPs a little bit smaller. It was a trade-off of it's more likely to work in more cases this way. So that's a big one. And the other params would be codec string and absolute codec string. Those allow you to edit and force the codecs that are being passed to the other side. So you can actually, even between the bridge, manipulate which codecs show up. So let's say you only ever want to pass through X, Y, and Z. You can force those. You can also mess with the codec prefs and the mix variables and which codecs are even loaded in order to limit which codecs get passed through as well. So lots of different methods. Again, check out that codec negotiation page on Confluence. It's page after page after page of information, lots of detail on how those work. Codec negotiation can be very complicated with different call flows, so check it out.
And then also, if I remember, years ago there was an entire ClueCon Weekly on codec negotiation. Right? Like
I
maybe
don't
2 years ago? I think Brian did it.
I don't recall. Hey guys, if you can find that, drop a link in the comments on this video, and people can check that out too.
Well, thank you, Mike. Answers from the experts. And now to you, Carol.
Hi. Are we here?
Hi, Carol. Thank you for
Hi.
coming in today. We're very happy to speak to you.
Hi, Mike.
So what
It's
do you
a pleasure.
what
It's
do
a
you have
pleasure.
cooking over there?
Well, as you see, I'm sitting in one of the several real-time communications labs here at IIT. So what I thought I would do today is show off a little of and give you a little history of where we came from and what we're doing today. So what you're looking at in the background here is the teaching portion, the teaching lab. And this is located in Chicago, Illinois, at 35th and State, actually in the research tower of Illinois Institute of Technology. So what I thought I'd start with you is tell you a little about what you're looking at, and then tell you historically how we got to where we are. Today, we are about to host our 14th annual Real-Time Communications Conference, which is now also associated with a hackathon called TADHack, and also associated with a juried papers component called IPTComm. So I'll tell you all about that. But I thought it would be fun to tell you where this came from. And first of all, to tell you that the lab is located in the School of Applied Technology. And if we can go for a moment to the lab's website. Can you
Guys,
show
you guys
that?
are doing some really cool and impressive stuff there.
Thank you. Thank you.
It's always good to hear about it.
Sure. So this is the where you can learn about almost up to date what we're doing. They can't keep up with us, so so sometimes you'll find that they're not quite as current as we may be. But here's where you can find links to the Real-Time Communications Conference, which is coming up, which the associated TADHack and ClueCon. Of course, that was where we just recently spoke. So there's that I wanted to share with you, and to point out that we're in the School of Applied Technology, which is a school I wanted to tell you a little bit about. So the School of Applied Technology within IIT strikes a balance between theory and practice, and that's its aspiration, is to have, for example, a project component in almost every one of the classes that are offered. I came to the school, let's see, you can come back to me if you want. Okay, I came to the school in 2003, attracted by this desire to integrate theory and practice, and they were attracted by my experience, which was many, many years in telecommunications and voice over IP and pre-voice over IP technologies. And they invited me to teach a course in what was then called voice over IP. That was before we called it real-time communications. So I was excited to try that, and did. At the time, there was no lab. And so I gave as a project a thought experiment, which was to figure out how to bring voice over IP to the campus. And we had a good time, and I was invited to teach again. So I said I would love to do that. However, this time we needed a lab, because my whole desire to bring theory and practice together would involve having a lab in which to do that. And
Yeah,
the university.
it's a lot easier to understand the technology when you actually see it function in front of you.
That's right. And also,
you get those moments where it just pops up and it goes, oh, that makes sense.
that's right. And in voice over IP and real-time communications, the really interesting thing that it's very hard for people to wrap their heads around when they're coming to it from the data communication side is the fact that the signaling is separated, is an entirely different channel, as it were, from the media. And there's nothing that brings that home so well as your traces, your Wireshark traces, and observing that the socket to which the RTP is attached is quite different from the socket to which the SIP signaling is attached, or the MGCP, which I also taught back then. So, so you can explain this and people can abstractly understand it, but they will consistently make the same mistake unless they actually have had to read the trace. So that was the idea, to get the lab. We did get the lab. That is, we got equipment for the lab, but we didn't actually have any space to put the equipment. So we got a rolling cart and put the equipment on the rolling cart, and I would roll it out of the closet in time to teach, and we would roll it back into the closet. And if we had problems, which we did, we would have to meet on Saturday mornings at the lab, and at the not lab, at the campus, roll it out of the closet again, and play most of the day trying to fix things. So that was fine, and we were a popular class, and voice over IP was a popular thing, and so they invited me to continue teaching. I said, that would be wonderful, but I don't want to teach it rolling it out of the closet anymore, so let's get a room. So
I got to tell you, it's a wonderful thing that you do, that you teach this, because in the end, it's something that I think a lot of schools, like, I think a lot of it gets associated with the MIS stuff and CS stuff, but it's always overlooked. There's never, it's just, it's not really something that most schools focus on. And to have a school that focus on it and have curriculum surrounding it, it's an important thing because it's a really integral part of our technology these days.
Yeah, I think that's very true. And what we get is either electrical engineering students or computer science students who may have been told sort of abstractly, here's how real-time communications or voice over IP work, but they're not. It's not taught as a separate, shall I call it, discipline or technology. And so they come out, and then it takes a company 6 months to a year before that person is able to be a real contributor in that space. It takes an amount of time to learn the lore, to learn the background, and to learn the details. There are huge numbers of details. And we change those details every week now. So yeah, I think that when the students graduate from this particular part of the program, they are getting hired as senior VoIP engineers, for example, which is not a very usual thing for a new graduate. But the level of experience they get from the projects as well as from the drill. I mean, we do labs in here, and you sit there and analyze your protocol traces until you understand what happened. Yeah, so I'm glad that that this is appreciated, because I think that the students also are.
I'll tell you, sometimes it even takes years to train people in this stuff in the actual workforce, because it's not full time. It's done, in piecemeal, and to have someone come in that actually understands how to diagnose networks and look at PCAPs and understand what's going on. I mean, that's an art unto its own.
I early on had that experience. One of my students was actually working, I think, as an internship at, I think it was Motorola at the time. And so he was carrying stuff back and forth between our lab and theirs. He was working and coming back. And he said one day he found himself surrounded by a bunch of engineers as he explained what was happening on this SIP call using his Wireshark. And it was an overwhelming experience for him. But what we find, what we know, is even after a year out of school, an engineer or a technologist's skills start to, he or she is drilling down into one silo of expertise, and they don't learn the latest. So the back and forth between the new graduate who understands the technology, the latest technology, and the more experienced, engineering group is really important. We also, by the way, do in our program people coming in with considerable experience, but who exactly need to learn, how to read the traces and how to understand. Here's my mantra. What is your application doing to the network, and what is the network doing to your application? Unless you're able to take a look at that, I think that you're not as valuable in the community, because somebody else is going to have to figure out what the network is doing to your application, or what the application is doing to the network. So yeah, we try to do that here, and so I could tell you more about that, and I could also show you some of the offerings that we have at the Real-Time Communications Conference. Those are the two things I thought we could continue to look at. But you had some questions
Great.
beyond, or comments?
Well, the one thing I wanted to say is we're going to be at the conference.
Yes, yes. Anthony Minasali is going to be talking, right? So we can flip over to that, and I think probably more than Anthony are going to be there. So let's take a look. There we go. So it's easy to find us. It's rtc-conference.com. And let's see, if you go to the program, then first of all, you can click on the draft schedule, which is clickable right here. But before I do that, I'll show you what the tracks are. So this is the juried papers. Vijay Gurbani and myself are co-chairing this. This is the 11th running of the IPTComm. And we have, I think, accepted 6 papers dealing in the area of real-time communications. IPTComm stands for IP telecommunications. Then we have a track called Programmable Telecom Applications. And following that, you can imagine what that is. Following that, we have one called Compressing the Stack, so methods for integrating application performance into the network layer. So we're going to actually...
That's interesting.
Yes, and we run those in the same, we're a 3-tracked conference, but the tracks refer to the time. So the tracks we're running programmable telecom applications back to back with compressing the stack. And that goes along with that mantra that I described to you, which is what is the network doing to your application? What is the application doing to the network? So the compressing the stack is focused on how to allow the network, or to you as an application developer might want to call upon the network itself to smooth your media flow, to smooth your information flow. And so we saw those as kind of related. There may be some, we hope actually, there will be a voicing of differences of opinion, whether you want a really dumb network or whether you want to be able to call upon that network to help your application. So we are planning on having some panel discussions and some individual presentations that will talk about the pros and cons of how smart do you want your network to be? Do you want to be in control of whether it uses its intelligence to help your application or not? So those should be very, very interesting. Maureen Stillman and Chris Mayer will be chairing the programmable telecom apps. And compressing the stack, we will have Charles Eckel and Mark Gibson Charles Eckel and Mark Gibson will be chairing that. Then
and so when we talk about like compressing the stack, is that things like addressing keeping things under MTU sizes? And because one of the things that happens is you might be able to control certain aspects of the network, but sooner or later that's going to get out of your control, because
that's right.
it's beyond it's beyond the size of the network that you actually have control over. So you can increase your MTU size, to like, 1600 or 1700, but once it leaves the border, it's a totally different issue, right?
That's a very good point you raised. So this is part of software-defined networks and network function virtualization, and so this is, we are in an experimental phase of the revolution of real-time communications and basically the whole internet/web, and I think you have to call it a revolution. That we're transforming all aspects of human social existence, from religion to medical to where you meet your spouse. I mean, everything now is we do business on this web, which is supported by IP. In popular culture, I think a lot of people don't even distinguish between web and IP, IP networks. So we're here at the point that there's experimentation going on. How much can I, as an application developer, will I find APIs? Will I find tools that will help my channels of information that need to flow across diverse networks owned by diverse, different administrations? Do I want some kind of guide that will help them find the most efficient path or the most reliable path? I mean,
And
we've
I think
been
without
doing
any
this ever
question,
since we invented the internet, but what?
yeah, but without any question, you could definitely call it a revolution.
Yeah.
And the easiest way to do it is you just look at the statistics. Like I think RTC, the adoption started out a little slow, but it's growing at such a staggering rate that, year after year, it's almost multiples. I think like 32 billion minutes were moved across RTC last year. The year
Yeah.
before it was a couple 100 million. Like that growth, that's a revolution.
That's right. And in the course of that revolution, as in the course of our lives as we know them, we tip a little bit to the one side and then we tip back to the other side, and you watch this rock back and forth. Do we want it centralized? Do we want it decentralized? Of course, we want both. And we find a sort of point in the middle at which we balance for a few moments. And then it tips to one way or the other. I mean, we oscillate between, let's centralize all the intelligence one place. Oh no, let's disperse it throughout the network. Both of these are correct, and they both have to do with the scale, the scope, where you are. So and I think it's going to be the same with this. So software-defined networks, network functional virtualization. The networks that we traverse are owned by one organization or another, and they have their own administrations. Even if you set up an IP network, you're going to have different rules for your routers, and they're going to be your decision what those rules are. So I've actually worked with the MEF, and they're actually a platinum sponsor of our conference the last couple of years. They're heavily involved in the development of standards for the use of software-defined networking and network function virtualization. So we started a project where we said, if you're going to automatically control the flow of information across diverse networks, how is that going to impact my real-time applications? Real-time applications, we know one of the many problems, since the internet was not really developed to carry real-time. It was really built at a time when they weren't anticipating putting voice and video over internet, right? We had to sort of go back and build many, many things to make it work, to make it do what we wanted it to do. So I lost my train of thought.
I heard a really interesting story recently,
Okay.
and it was about FaceTime. And one of the things Apple did was Apple went into and put equipment everywhere in order to address some of the latency issues and things you're talking about. And it was a really smart thing for Apple to do. Like really
Yeah, that
smart.
reminded me. That reminded me. So yeah, so what we thank you. So the idea was if we do a real-time application, a real-time communication, say a WebRTC call, video call, you start making automated changes as the network seems to require. Am I going to lose, for example, my RTP streams? Are you going to, if you
True. Especially you start talking about like things like Anycast and stuff. It's like
that's right, that's
well,
right. And so this is an ongoing. That's right.
Come back.
Or will it come back? Right. What if you, okay, you're going to spin up a couple of new routers, or you're going to spin up, some new network functions? Are you going to be able to tell them about how they have to carry my RTP? Am I going to get one-way communication, video or audio? So I think that's an area of study. And it exactly talks to what's your network doing to the application and what's the application doing to the network. So yeah, there's a lot to be looked at. And I guess what I'm saying is I want to see that discussion take place in the conference. Another thing that we are going to see discussed in the conference is, could there be an WebRTC-based solution to emergency calling? So, one of the things that our lab has focused on very much the last, actually, many years has been delivering next generation emergency communication services that would be over internet. So,
yeah, you have a solution. It has something to do with Bluetooth and GPS locations of the handsets?
Yes. So if I could take you to the slides, we have a couple of sets of slides. More than 10,000 people who would otherwise be saved die every year when 911 call from a cell phone because the dispatchers can't get to them quickly enough because they can't identify their indoor location. So our solution is based on an array of Bluetooth beacons, and this could also be a set of Wi-Fi access points, and we have done that work as well. But here we have an array of Bluetooth beacons. We have a location server with its associated database, so we have basically a number of APIs that are written over here. We have built a smartphone module here, which is going to call for a emergency support, and we have our own emergency services IP backbone network, which is fondly referred to by the National Emergency Numbers Association as the ETSI. So we have all this infrastructure built in our lab. We built a cell phone application, which upon when you call for when you call emergency, it will scan the area for Bluetooth beacons. It will record or will learn their RSSI, that would be their received signal strength, and it will send that information into our APIs associated with our database. In the database, we have recorded the locations of the Bluetooth devices, and we have this as a living project here at IIT. So we've fitted three of our buildings with the Bluetooth beacons, and we record where we put them, and they're actually XY coordinates per floor, and we record their floor. So using a process of trilateration and least squares fitting, we come up with a very accurate prediction of where the person is actually calling from. We send that information presently back to the phone, who then makes a SIP call, and the call is answered by a public safety answering point operator. We have that, and we have, this is an ongoing project, and we have a video of it, but I think do we have time to show that video? And then I'll tell you about the next steps there.
Sure, but before we do that, so
Yeah.
why don't we talk about what the problem is with the existing 911 system? So
Oh,
why
yeah.
is this more accurate than, doing like a traditional, I guess, like, HLR, VLR or something like that?
So sure. So actually, emergency services is lagged very far behind things like delivering pizzas, right? I mean, emergency services traditionally and still today is handled by circuit switch technologies. So in circuit switch technologies, it was predicated on the fact that you would have a wire connecting your phone to the central office. So there would be administrative records that told the operator or that told the telephone company where that phone was. So it was a fairly simple operation to use what was called a selective router. When you made a call, a circuit switch call over wire, then everybody knew where that wire ended up. So it was associated with an address. So that address
We're
was then
talking about
used.
SS7.
Wasn't even SS7. I mean, that was just records that said where this pair of wires that comes into the central office, where's the other end of it? So I know it comes into the Edgewater office, and the other end of it is located at this address on Winnemac. And there would be in that office a function that at the switch would see, oh, this is a 911 call, so I'll send it over to the selective router, and it will be directly connected to, or we'll make a connection directly to the appropriate public safety answering point. So there would be an operator sitting there getting all the calls from that area, anything that switch. This was generations ago. This was when everybody was using this was circuit. Cell has a more difficult time and doesn't do so well always in locating you. They use triangulation methods and GPS, but GPS doesn't work very well in tall buildings. In fact, it doesn't work very well indoors. And so the FCC about 2014, I think, came out with a mandate that said if you're a cellular carrier, you need to provide a method for discovering the indoor location of a caller in a tall building. And it cannot be GPS. You have to do better than that. We want you to use, they mandated that they get within 50 meters of a person in a building. And so we started this project because T-Mobile was one of, I think, 5 carriers that banded together and said, we have to get a solution for this. And they just asked us if we could come up with a proof of concept. And it had to be based from their perspective on either an infrastructure that was recorded. It either had to be your wireless access points, or it had to be an infrastructure that you put in place, purpose-built, Bluetooth. Or perhaps not purpose-built, but then you would have to figure out how to use existing signals in a reliable way. But they said Bluetooth or Wi-Fi access points should be the basis for this determination. So we did it first with Wi-Fi, and then we thought it would be fun to do it with Bluetooth, and so that's what we've got. And right now this project has a life of its own, and will not go away. We're close to the point where the code is hard enough that one could consider, we've already been asked, could we put this into our building? And who asked us this? It was architectural engineers, because our beacons, we're using them to identify location in emergencies. So, of course, it would be very useful for if there were a fire in a building. We also have on those same beacons, we have sensors that detect the temperature and humidity. So if there's a fire in your building and you notice that it's 451 degrees Fahrenheit on one side of the building before my sensors melt, then you know that the firefighter should go up the other stairs. So all those things are possible with this infrastructure. It is an infrastructure that has to be put in, but the beacons don't cost.
From a practicality standpoint, I mean, just think of the concept of using your example of, Bluetooth needs power, right? Not a lot of power, but you can't. It would be very easy to integrate this into a smoke detector,
Of course. Yeah. And
right? And
we've had,
that's something that can be rolled out, as a national initiative to upgrade your smoke detectors. And all of a sudden,
sure.
you have
And if you
indoor
put them,
911 detection.
right, if you put them in where you've got your emergency lighting systems, where you've got your smoke detectors, where you've got your defibrillators, you're already supplying emergency power to those. And yeah, you could definitely do that. Definitely do that. And we have by now built a lot of the actual coding that needs to be done in this has to do with the operations and maintenance. If you're going to deploy an array of Bluetooth beacons, you got to keep track of them. You know where you put them, but what if their batteries are dying? What if somebody pulls them down off of the walls? What if they fall off the walls? All of these things. So they're like little cron jobs and other things that have to run on your database. You're picking up information from your beacons. And a lot of the information simply is related to the maintenance of that infrastructure. Because if, for example, somebody were to switch two of your beacons, and I'm using their XY coordinates per floor to calculate where you are, and the power in the signal, my algorithm is going to produce a wrong. It won't give you an accurate location for where they are. We get about 3 meters away in the majority of our cases, so we get very, very high accuracy. So, and as you say, the investment isn't that great, and people who run buildings and who want to be able to advertise about this building, this is a 21st century building and it can save your life, or help you regulate your HVAC, which is also what can be done with these. You have now multi-purpose from the same installation. I did want to get back and answer why is this better than the old way. But the main thing is that we can't find people indoors very well with GPS. I mean, even in downtown, you sometimes can't find the GPS won't be very accurate just because of the blocking of the signals by the tall buildings. So I mean, I've frequently seen myself swimming across the river,
Yeah.
using
and especially
map.
It's a signal propagation through like you look at some of the old stone buildings and there's no propagation through those.
That's right. So this helps with that. And several years ago, even, there was a lot of even people on the late night television shows talking about how ridiculous it is that the pizza delivery man can find you, but the emergency services people can't. And of course, it was tragic as well as funny, but that is something that's part of the revolution. And of course, the revolution
So from a mobile perspective, what's the accuracy outside? Because a lot of times they're not even pulling GPS. They're pulling the cell tower IDs, and that's only like,
that's right.
At a maximum like 330 meters, I think. Right?
Yeah, well, yeah. So that's true, and part of the revolution, right? It is true, and outdoors that continues to be a problem. And there've been many mandates, but there haven't been. It's been slower actually to evolve. Indoors, I think we have both between Wi-Fi and Bluetooth and more control. An initiative called the NEAD, the National Emergency Address Database, which was designed to collect exactly this kind of information from individuals and companies that had infrastructure that they could then they would say, here's where my Wi-Fi access points are, here's where the Bluetooth devices in my buildings are. But at present, this is a voluntary and very slow process. And yet the NEAD will have to have processing probably comparable to the processing that we've developed that would actually take RSSI information associated with location and calculate where the caller is actually located. This also means that you have to have maps of the buildings, really. And now what we have is we built a prototype all-web solution so that we're not even, if I can go back to that, where was it? Yeah. You go back here. I showed us sending the location information through a SIP call, but we've developed later an all-web solution so that this caller is now using a web application or is communicating directly using web rather than a SIP-based application. So as signaling goes up here, we have then a signaling path in the web socket from here to the actual WebRTC PSAP. And one of our initiatives this year, and we're hoping to have a panel discuss this at the conference, is how do your requirements change when you attempt an all-web solution? So now I can keep so much more information I can keep real-time information in my database, including the tag on this call, and associate with that his location. So he's not anymore sending his location this way. It's being stored in real time here. So there are many possibilities that are not yet standardized, but would be exactly the kind of thing that the research and development communities are going to want to look at.
But sending a pure SIP call could be relatively easy if you start working with an organization like Google, because
we do that.
They can,
yeah.
they just push it into the firmware and it gets out to everybody, right?
Yeah,
And
exactly.
what's the saturation rate for Android phones? It's like they control a very substantial amount of the market.
See, our application is an Android application, and it works quite well. We have very low latency getting back from the APIs the information about where your location is, and that is sent into the emergency services IP backbone network and carried all across that network. That network we have.
So does it use the native Android SIP stack, or are you using your own custom SIP stack?
We didn't use Android, so we used a different one. But see, that was where we wanted to go up, and instead of having it Android specific, we wanted to make it platform agnostic. And there are tools to do that, but we discovered, we're a school, so our projects have not necessarily cutoffs, but they're semester limited. And what the students found is to learn the tools that would allow them to do this in a platform independent method was probably going to take them a good chunk of the semester. So for several semesters, we have not done that because of simply the lack of the learning curve. And that's why doing the WebRTC, I can bring up a browser. And on the Android phone or the iPhone or anybody else's phone, and it kind of got through that. Otherwise, yes, you would have to basically port your code that we have written for Android. You have to port it to iPhone and whatever other platform it needed. And it's a question of where you put your energy. So in a way, we treat it like a proof of concept, but in another way, we thought, you have to look at what are the requirements for emergency services communications, and one of them, your network, your application can never fail, and you have to always be able to talk to the caller in need and so forth. And so what I've seen is when requirements get written by standards bodies, they are frequently unintentionally too specific to whatever the current state of the art or the platform is. And, so they become less high level requirements and more requirements that are specific to, this is the IP networks that we know today, or this is the circuit switch networks that we know today. And so some of the requirements that are on a person or an organization that provides emergency, some of them are very specific to the internet protocol, but have yet to be translated perhaps to a web communications path. That's a very interesting project, actually, I think. We work with the National Emergency Numbers Association. We have their ETSInet built multiple times in our labs. And so, and we test, we do every year, we do these industry collaboration events in which we have one step more maybe controlled than a plug fest. So vendors of functions that need to be supplied to emergency services, they bring their applications and they make sure they can interoperate. So.
Well, that's a very noble thing you're doing. That's for sure. You should be very
well, in
proud.
a way. Well, we are actually. But it's something, especially with students, I think, and especially with the research community. You want to feel like the work that you're doing, the research that you're doing, is kind of helping mankind, and I definitely think this does. So, yeah, and we learn a lot on the way. I know we're running out of time, but one of the student projects over the summer was to make a smart speaker call to our ETSInet, and he did. He made it using Alexa. So we created an Alexa skill and managed to call 911 using that. So, and of course using a WebRTC cloud service to do the translation from a web call to a SIP call, so that it could, now SIP has become, I am told, legacy. And so yeah.
Well,
So we
thank you
actually
for
made
coming
it
in
as a
today.
legacy call. All right,
Yeah,
thanks a lot for having me. It was great to talk
thank
to
you
you.
so much.
Yeah.
And so you want to tell us more about your event coming up? It's just a couple of weeks, right?
Yeah, here it is. So the event, let me just show you this one other thing. So we're now flipping here. The co-located events, you got to take a look at TADHack. It's the weekend before the event. So it's October 13th and 14th. It's taking place right here at IIT. And it does, and you can win prizes, fabulous prizes, $1,000 prizes. This is part of Global TADHack, and TADHack stands for Telecommunication Application Developers Hackathon. So
And they
there's
also
that.
have TAD Summit as well, right?
Yeah, right. All of that you can find there just by going into co-located events. And we have tutorials running on Monday. Yep, pre-conference tutorials. You can sign up for them. If you're too busy to come to the conference, you can pay a small amount of money and you can take either Bernarda Boba from Microsoft talking about WebRTC from 9 to noon, or you can get Model-Driven Network Programmability from 1 to 4 by Charles Eckel from Cisco. So these are two great options. And let's see, where were we? Oh, I told you that we have IPTComm. So you can read, this is more if you were writing a paper. So they've already been approved. So let's go back. Yeah, so to
And of course, we're
Go
gonna see
ahead.
you there.
Yes, you
So
will see us there. And if you want to take a look, I just got to show you this one more wonderful thing. If you want to go through alphabetized by their first name, you can find all of the speakers for whom we have all the information. Now, there are some speakers who are shy and who have not provided us yet with all their information, so you won't find them here because
it
we
always
have an
happens.
automated what? It always
It always
happens.
happens.
Yeah, that's right. We're down to those last 3 weeks here. But to show you, if you go to click on the presentation, you will find out what its abstract is, and you can even find out about who the speaker is. So you'll find their bios. And after the conference, the presentation slides will be available here, so you'll be able to see them afterwards. So we're very proud of our automated program here. So you can have a look at that.
All right. Well, thank you, Carol, for coming in today.
Okay, well, thanks a
Um,
lot for asking me. It was a lot of fun, Mike.
yeah.
Okay.
And we'd like to see you again soon. Back to you, Ken.
Okay.
All right, guys. Thank you very much, Miss Carol
Oh, sure.
and Mr. Mavrutis. We'll see you guys around again in the near future. And for everybody else, don't forget, thanks for coming in and joining us today. If you have ideas for ClueCon Weekly, hit us up on any of the social media or drop an email to marketing@cluecon.com and let us know what your ideas are, and so we can, so the scheduling team can get those people on the schedule and get them in here for us. Also, don't forget, for you guys watching us on YouTube, click that subscribe button down below and hit the little bell icon there next to the subscribe button once you've done that, and you'll get notifications when we're going live next, as well as notifications for other videos that we'll be posting across time. Anyway, thank you again, Miss Carol, and you guys don't forget to go check out their conference there at the ITT, and that's coming up real soon. You can also see Anthony Minasali there and a lot of the other FreeSwitch and SignalWire teams, so you guys check that out. And we'll see you back here on ClueCon Weekly next week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at freeswitch.com.